Hello, my amazing students. This is Mrs. A, and I am finally getting around to giving you our videos for Chapter 8. So this is 8.1, and this is on simplifying, multiplying, and dividing rational expressions and functions. So the first one that I'm going to do for you is a rational function. And remember that rational expressions and functions are simply fractions made up of polynomials. Okay, so we have a polynomial on the top and we have a polynomial on the bottom. And this was a three-part question on the study guide, and it said find f of 5, which means that I'm going to go in here and put 5 everywhere that there is an x. So that's going to be 25. Take away 16 on the top, and on the bottom it will be 5 plus 3. Then 25 take away 16 is 9, and 5 plus 3 is 8. So the A portion of the answer is 9/8. Then it says find x so that f of x is 0. So we're not substituting in a 0. We're setting the f of x equal to 0. Okay? Now, in any fraction, if 0 is on the numerator, won't 0 be the final result? So when we set the function equal to 0, what we're really thinking about is just setting the numerator equal to 0. So we have x squared minus 16 equals 0, and we know that that is going to be plus or minus 4. I could factor this into conjugates, x plus 4, x minus 4, and the answer to part B is plus and minus 4. Okay, are the two x values that will make the whole function go to 0. The last one is the domain of this function. For the domain of a rational expression, you look at the denominator, and if the denominator goes to 0, you have to exclude those values from your domain. So x plus 3 equals 0 when, so basically I said x plus 3 cannot equal 0, and that happens when x is negative 3. So I have x cannot be negative 3. Okay, how do I write that expression correctly as a domain? Okay, so I'm going to take a little bit of space from up here, since I don't have any extra boards, and I'm going to write x cannot equal negative 3 properly as negative infinity to negative 3 union negative 3 to positive infinity. So this is the correct way to write that domain in your interval notation. So now we move on to the next board, which is a function, g of t, and we are to write its domain. Okay, so the first thing I'm going to have to do is factor this denominator, because remember, the domain has to deal with the denominator. The denominator cannot go to 0. When I have a quadratic denominator, I need to factor it. So we're going to factor the denominator. It's going to have a t and a t, and I'm thinking of factors of 36 that will subtract to 5, and that would be 9 and 4. So then I have to make sure my negative 5t in the middle means that my greater number will be negative, my smaller number 4 will be positive, and now I have factored. That doesn't look like a t, does it? All right, so I've got t minus 9, t plus 4, and when I FOIL that together, can you confirm that I get my original denominator? And I do. So now I'm going to set each factor equal to 0, and those will be the values that I exclude. So I'm going to exclude, so I'm going to say t cannot be 9 and negative 4. Okay, so since t cannot be 9 or negative 4, I'm going to write my domain down here. I'm going to try to give it a spot here since I've got no extra boards here. So now I'm going to write this domain here. It cannot be 9 or negative 4. So negative infinity, remember your domains are always written in number line order. So I'm going to go to negative 4. I'm going to put a parenthesis, union, a negative 4, comma, 9, union, 9, comma, infinity. Okay, so negative infinity to negative 4, union, negative 4 to 9, union, 9 to infinity. And that's the domain of the first problem. Now let's look down here. We're to find the domain of this second rational expression, but notice that this second rational expression has not got a variable on the denominator. It just has a constant. Therefore, all real numbers will be okay, and no denominators will make it go undefined. So we just say negative infinity to positive infinity with a paren and a paren, and we have that one done. The next one we're going to do, now we're working on simplifying or writing rational expressions in lowest terms. Okay, so on this first one, we're going to simply cancel the 48 and the 4, and 48 divides by 4 with a 12 and a 1, and then n 8 over n to the 4. Remember, when I divide like bases, I subtract their exponents. So I'm going to wind up with 12 n to the 4th. And that's the answer to that one. Down here, it's a little bit more complicated because I do have an expression on both the numerator and the denominator that I can cancel, I can factor. So remember, I cannot cancel what I cannot factor, so I'm going to simplify by first factoring the numerator, factoring the denominator, and then canceling anything that I can. So the numerator is going to become 3 times m plus 6, and then my denominator is going to, I'm going to pull out a 5m. So I'm going to pull out a 5m, and when I pull out a 5m, I get an m left and a plus 6. Okay, so I get a 3m plus 6 over a 5m times m plus 6. The m plus 6 will cancel, and I'm going to be left with 3 over 5m as my final simplification of my rational expression. Okay, so the next one that we're going to do is just a little bit more complicated. Okay, the numerator is going to factor with a 7. So I'm going to pull out a 7. And then the numerator is going to be a 4x squared minus 1. But that numerator still has a factorable term here. I can factor this little binomial. It's a difference of 2 squares. So I will factor it into conjugates. So coming down here, this numerator will become 7 times 2x minus 1, 2x plus 1. My 4x squared minus 1, difference of 2 squares, factors into conjugates. Then I'm going to start working on the denominator. And the first thing I'm going to do is pull out a 3. I always want to make things just as easy as I can. I pull out the 3, and I'm going to get a 2x squared plus 3 minus 2. Okay, so when I go to factor, I'm going to have a 2x and a x here. I'm going to bring down my 3 so I don't lose it. I know I've got to have a 2 and a 1 as factors of my last term here. But notice that if I put a 2 here, I would have a 2 factor out of here, and I've already pulled out the only factor that I have is the 3. I'm trying to get that little glare off of my board there. Okay, so I'm going to have to put the 2 over here, and I'm going to then put the 1 here, and then I'm going to look for which signs will make this true. I got a 1x and a 4x. I want a positive. Oops, do you see right there? I lost my x. X and minus. Okay, so I lost my x there. But I do have a 3x positive in the middle, so I'll make the 4x positive, the 1x negative, and now when I FOIL that together, I do get my equation. I remembered to bring down my 3, so I factored everything. Now my 2x minus 1 and my 2x minus 1 will cancel, and my final answer is going to be 7 times 2x plus 1 divided by 3 times x plus 2. So basically all of this with this canceled out. But I'm not going to write it again because I don't have any more boards. And the last one, we have 2 that we get to factor here. The numerator is going to factor z and z. The denominator, remember we've got same sign, both positive, so I can go ahead and put those in. 28 factors 7 and 4, which happens to add to 11. So 7, 4 factors pretty easily. And then on the bottom, I've got z, and z, my first inclination would be to say, is that a perfect square trinomial? Because I have a perfect square on the front, I have a perfect square on the back, and if I take 7 and z, and I multiply them, and then I double them, I do get 14z. So I'm going to have z plus 7, or z plus 7 squared. Now my z plus 7 and my z plus 7 will cancel, leaving me with the final answer being z plus 4 over z plus 7. And I will be back with more. Okay, so now we are going to talk about what happens when we have c minus 7 and 7 minus c. These are negatives of each other. If I took negative 1 times c minus 7, I would wind up with negative c plus 7, which could be written as 7 minus c. So the two are exactly negative 1 times each other. If I multiply this one by negative 1, then lo and behold, I get negative 7 plus c, which is c minus 7, and I go back to that one. So anytime we have two of these, okay, they're negatives of each other, we will just reduce them with a negative 1. So the answer to that one is negative 1. They reduce completely. Okay, so along that vein, we're going to factor the denominator into, this is a difference of 2 squares. So we're going to factor it as 11 minus 4z, 11 plus 4z. Okay, so now we're done with that one. Now 4z minus 11 is the negative of 11 minus 4z. So we're going to cancel this one and this one, leaving a negative 1. Usually we leave that negative 1 in the numerator, and then our final answer is negative 1 over 11 plus 4z, or 4z plus 11. I kind of like to put mine in the correct descending order of the variable when I can, and so that would be the answer to that one. The next one is we're going to have to factor the numerator, and if we factor out a 6w out of the numerator, we're going to have a 9 minus w squared. Okay, and if we factor the denominator, it's going to be a w plus 3, let's see, w minus 3 squared. Okay, now it looks like we're kind of stuck, but we're not, because we have not completely factored the numerator yet. Okay, so this one down here on the bottom, I'm going to draw one nice line all the way across. This one on the bottom, the denominator, is a perfect square trinomial, because when you take the w and the 3 and you multiply them and you double it, you do get the 6w in the middle. So it's going to be w minus 3 squared. The trick is that this one is not completely factored. So we're going to turn this one into, since this is a difference of 2 squares, we're going to take this into conjugates, which is going to be 3 plus w, 3 minus w. So we're going to take this one out here because of board space and make this 3 plus w, 3 minus w, and now because we have a w plus 3 and a w minus 3 and a 3 minus w, these are negatives of each other. So when we cancel this one and one of these, I'll just cancel out the square, we're going to leave a negative 1 up there. So the final answer for this one is going to be negative 6w times w plus 3, no harm in turning that one around, divided by w minus 3. And that should be the correct answer on that one. Okay, everybody see that one? Okay, and so this one is asking us to write this expression in 3 more equivalent ways. Okay, and this is still dealing with the 9 minus x, x minus 9 being the same thing except for multiplied by negative 1. So if we were just trying to flop this negative sign to several different places, we could write this one as 5x times x plus 2, and then we could take that negative sign and flip this around and make this x minus 9, and that would be correct. Okay, we could take this expression here and we could make it a let's see, I'm going to cheat a little bit here because this is, I don't always think of these because I don't think of having the negative in the front. So we could make a negative down here. So we could just put the negative also, well, let's not change that one. Let's go down here and say 5x, x plus 2. And then we could say over negative 9 minus x. So in other words, we could leave the negative outstanding there, and that would work. And we could distribute the negative through, so we could leave this 5x over x plus 2, and then on the bottom we could leave negative 9 plus x, which is the same thing as x minus 9. So we're just talking about several different ways that you could express the same thing. And basically, for the most part, this is usually my responsibility. But if you had a multiple choice question and you had to recognize the correct answer, then that would be your responsibility. Okay, generally we like to leave things looking as nice as we can. I would definitely prefer this as a correct answer because look, I've got descending order of the variable, which is always a plus, and I have fewer negative signs, and it means the same thing. So I go with descending order of the variable and fewer negative signs any old day. Okay, so now we're starting to work on multiplying rational expressions. So we're kind of doing a freshen up our concepts on just multiplying fractions, because remember, rational expressions are just fractions made up of polynomials. So if we were going to multiply, wouldn't we try to factor and cancel? So since I can divide 20 by 5 and get a 4, and 5 by 5 and get a 1, I can do that. I can divide both the top and the bottom by 5, and I can divide the top and the bottom by 9 also. And remember, I cannot cancel what I can't factor. But now I wind up with 1 over 8 being my simplified expression, in this case a fraction, and much easier to look at than what we had before. So now this is where the plot thickens. Okay, so now we have rational expressions that we're multiplying together. And so we're going to factor. So this one can factor out a 3. So I'm going to have 3c minus 4 over, now this one I could factor out a 2 because I see a 2 over there. I'll just go ahead and factor out a 2. 2 times 4, c to the 10. And then over here I've got a 2, c to the 4 that I'll write down. Down here, this factors into a c minus 4, c plus 4 into conjugates. So now I can cancel all of my like factors. So c minus 4 on the top, and then a 2 and a 2 on the bottom. That was a 2 times 4 if you can't see it there, 2 times 4. And then I've got my c's. Since I have 4 c's here and 10 c's here, 4 c's will cancel out of both, leaving a, let's just erase that, leaving a 6, okay, c's. And my final answer is going to be 3, that's all that's left on the top, 3 over 4, oops, I lost this one, I'm going to have to stretch this out a little bit, 4c to the 6th, and then c plus 4. C plus 4, tiny. Okay, 4c to the 6th times c plus 4. I'm sorry, I ran out of room there. Okay, so the next one is not too complicated. So we have a 6 and a 3. So we're going to cancel out the 6 and the 3. We've got a y cubed and a y, so I'm going to just make this a y squared and cancel out that y. I've got a z squared and a z to the 4th on the bottom, which I can cancel out that z to the 4th and make it a z squared. And my final answer is 2y squared over 11z squared. Okay, 2y squared over 11z squared is correct. The last one is fun, and I had to write it tiny. Can you see it? Okay, because it's a big problem. Now, this is the type of problem that I put down on the board for you, and I said, you know what? The way I do it is I write my problem in the middle of the board so that I have room to factor up here, factor down here, because the less I copy my problem over, the fewer mistakes I usually make. So this one up here, since there is no greatest common factor, I'm going to be able to factor this one with a 2d and a d, because there's only one way to get 2d squared. Then a 5. Now 5 is going to either go here or here, but if I put the 5 here, then I'm going to have a 10, and I don't want to go that high. So I'm going to put the 5 here. I'm going to put the 1 here. I'm going to want a minus 3d, so I'm going to put a minus 5d and a plus on the 2d, and it FOILs to give me my original expression. Okay, so then here on this one, I'm going to factor out a 4 first. Okay, I'm going to move this one over just a little bit because he's kind of big. Okay, so I'm going to factor a 4 out. And then what am I going to have left? D squared plus 4d plus 4. Okay, so I think that's going to end up being a 2 and a 2, but let's see. That's going to be 4 times d plus 2 squared. Okay, am I right? So the first one squared, the product doubled and the last one squared. Yes, it is. Okay, so 4 times d plus 2 squared. We'll write that in a minute. Again, on the bottom down here, we've got a 2 that we can pull out. And we got a d squared plus 3d plus 2. And factoring again, I got d plus 2, d plus 1. And when I FOIL, I do get my 3d there in the middle. Can you see? And last over here, I'm going to pull out a 2d. Okay, and the 2d is going to leave a 2d minus 5. Okay, 2d minus 5. So now I'm going to switch the color of my pen here just to help it be a little bit clearer what is being canceled. I'll switch to green. Purple and green. Okay, so now remember, the thing I'm not going to copy this again. I'm just going to mark off what we're not using. Okay, so right here are the factors for this one. So I'm going to cross this out. And then remember, right here, t-tiny, for d plus 2 squared. I'm going to cross this one out and this one out because I'm using this one right here, this little bitty one. And then I'm crossing out that one because this is what I'm using. And I'm going to cross out that one because this is what I'm using. Okay, so there's our board, and we're looking for matching factors on the numerator and the denominator. Okay, so over here, I have a d plus 2 squared. And he's so tiny, I don't want to forget him. So I'm going to go ahead and take this d plus 2 and the square off of this one. So d plus 2 on the bottom, and then I'm going to take off this square. Okay, so everybody knows what I did. I canceled out one of the squares up there. All right, so then I've got a 2 and a 2 and a 4. So I'm going to cancel the 2 and the 2 in the denominator with the 4 in the numerator. I've got a d plus 1 down here and a d plus 1 up there. I've got a 2d minus 5 and a 2d minus 5. Okay, so when I look real carefully for any factors that maybe I missed, I'm going, okay, I got everything except for a d plus 2 on the numerator. And when I look through here, I've got a little d there on the denominator, and d plus 2 over d was the final answer there. Wow. That one was a little bit messy, but hopefully you were able to follow me all the way through. Now we're going to come back and do some division of rational expressions. All right, so we have only 3 more boards left to finish 8.1. So we're getting close. Now we're talking about division of rational expressions. And of course, we're going to divide by multiplying by the reciprocal. So we're going to have 42b to the 6th over c cubed times, we're going to flip c to the 5 over 2b, and we're going to multiply. When we do that, my 42 and my 2 will cancel with a 21. My c to the 3rd and c to the 5th will cancel with a c squared. And my b to the 6th will cancel, leaving a b to the 5th upstairs. And I wind up with 21 b to the 5th c squared with nothing left on the bottom. And that should be correct. It's a very long tail on my 2. Okay, and then on the next one, we again have a rational expression divided by a rational expression. So we're going to flip the second expression over, and I'm just going to write it down here so that I can turn around and write it up there, because I don't want to copy the first one over again. So we're going to flip this over and move it up. 16 over 12r minus 3r squared. When I write these on my paper to do them myself on a test, I flip them right away. Okay, so I don't even write them with a division sign. When I write them as a multiplication problem. Okay, so now we need to factor so that we can find anything that will cancel. So we're going to factor this first one, and it's going to be R. Now 36 is a 9 times a 4, and this plus means same sign, both negative, so we can use 9 and 4. And that does give me a negative 13 in the middle. 2 will factor out of the denominator, leaving an R plus 5. The numerator is 16, which can cancel with the 2 here, so we'll just write it 8 times 2, because we see a 2 down here. And then on this one, we're going to factor out a 3 and an R, leaving me with a 4 minus R. Okay, so we got the 4 minus R and the R minus 4 going on here. So I'm going to go ahead and cancel the 4 minus R and the R minus 4, leaving a minus sign upstairs. And we have a 2 that will cancel with the 2 upstairs. And I am looking carefully for other factors, and I am not seeing anything. So I'm going to write down negative 8 from over here times R minus 9 divided by 3R R plus 5. Okay, and that is the correct answer as listed, so I guess we did that one right. I've got the answers in front of me. Okay, and then the last one that we're doing on 8.1 is right here. We're going to change it to division. Now, since this is in the numerator, it would be over that, so I'm just going to kind of cheat, and I'm going to flip it like that and put a times sign, and I'm just going to know that that's really a little lower down than it appears, because like I said, the more I write it, the more apt I am to make errors. So I'm going to factor this numerator, and this little factoring trick I use often. Wouldn't it be cool if 3n plus 2 was one of my factors here? So I'm going to try and see if 3n plus 2 is a factor by using it in my trial and error as my first attempt. If 2 was here, then wouldn't negative 8 have to be here? And if 3 was there, a 1n would have to be here. And since that's a negative 8, we'll put the minus here. So then I FOIL this, and I say, okay, 3n squared minus 24 plus 2n is going to give me my minus 22n and a minus 16. So yes, this did factor here. So now I'm going to have what? Since this is a denominator and this is a numerator, I'm going to take my square off and cancel the 3n plus 2. So I canceled the square and the 3n plus 2, and I am left with an n minus 8 all over n squared times 3. This is in the denominator, remember, 3n plus 2. And that, my dear amazing students, is the end of 8.1. And I will try to get 8.2 up for you again tonight, a little bit later on. And this is Mrs. A, and may God bless your day.